Hello. Alrighty, let's get into our lesson 18. Lesson 18 transitions out of what we were doing for the past few weeks, I guess now, with our mid-unit assessment and everything that encompassed that, talking about what equations are, what systems of equations are, and now we're really building off of that. And so today we're going to be talking about what inequalities are. And you should be familiar with what inequalities are from your previous years in schooling. But today and tomorrow, while you're working through lesson 18 and 19, you'll be practicing what inequalities, how to write inequalities from a context, and then we're going to talk about systems of linear equalities to finish up our unit 2. So this is our last leg of it. We're about to get to the end. Today we're going to be writing inequalities that represent constraints in a situation. So in the beginning of today is just a review. We're reviewing, right, what do the symbols mean and how can we remember how to write inequalities? Remember, when it comes to inequalities, you have a solution set, right? A group of solutions that can be solutions to your inequality. For example, when it comes to our first equation, inequality here, I know that h can be any number over 50. So that could be 60 is greater than 50, which is true. I can have 65 is greater than 50, which is true. And so before, when we had an equation, we usually had one solution that would be the solution to our equation, right? If I had 2a equals 4, I know that a is definitely going to equal 2, and I have one solution. And so when it comes to inequalities, we have more than one solution. And so you want to get some practice working with how can I write these inequalities and how can I interpret them. And so 8.1 is just some practice interpreting what a solution, whether each of these things are solutions to any of the inequalities. And on the next slide, you do some practicing working with seeing it in a context. And so, right, I missed one. I was like, I knew I missed a slide. In 8.1a, you are practicing figuring out what the inequality actually represents. What does greater than look like? What does less than or equal to look like? What does greater than or equal to look like? Right, all things we've been doing before. And so 8.1b we just talked about. 8.2a talks about how to create inequalities in a context. Right, it gives you a bunch of information here, and it wants you to interpret what is meant by each inequality. So for example, I know that last year 120 people attended this senior ball that was being held pre-COVID. Obviously, it was a success and expected to be even bigger this year, and you were up to 200 people, right? We're starting to see new vocabulary in our words here, right? What does up to mean? There needs to be at least one chaperone for every 20 students. Ticket prices cannot exceed $20 per person, and the revenue from the ticket sales need to cover the cost of meals, so they need to make a profit of at least. So we want to start building our verbal language. What does at least represent mathematically? What does not exceed represent mathematically? And so here are some inequalities you'll be practicing with. And on the next slide, let's see, I'll choose one. We have C is greater than or equal to P over 20. Right, that is one of my inequalities on the following slide. And so we want to take a look at what does that represent. And so where do I see 20? Okay, I see a 20 here, and I see a 20 here. So if I'm looking at not exceeding, that means I'm not passing this number. So I know that it's going to have to be, my variable will have to be less than or equal to, less than, maybe, or equal to. So I don't have, this is a greater than or equal to sign, so not what I need. And so let's see, I have another 20 up here. And so what does at least mean? At least means that it has to be greater than or equal to. Right, at least that number. And so that means I know I'm talking about this situation here. And so from all of that information, I can write down that we have C is greater than or equal to P over 20 means that the number of chaperones, which is my C, chaperones, which is my variable C, must be greater than 1 over 20, right? 1 over 20 of the number of people attending, a number of students specifically, right? If we go back to this scenario, there needs to be at least one chaperone for every 20 students. So you know the ratio is one chaperone for 20 students. And so you can see it on the following slide that the number of chaperones must be greater than 1/20th of the number of people waiting. So you can, there's just different ways of looking at it. So try the other 3 scenarios and see what you can find through that situation. And then we go the opposite way, right? We have our elevator constraints, right? Held at most 50 people. Each car can carry a max of 1,500 kilograms. On average, an adult weighs 70 kilograms. An adult weighs, and a child weighs 35 kilograms. Assuming each person carries 4 kilograms of gear with them. For those of you who are interested in engineering, at some point, then this is something that will be a usual problem for you understanding what our constraints are and what you can and cannot use, right? So you want to create inequations or inequalities that you can think of, right? Remember, you can represent your variable, right? For example, if I have my variable, let's say A is the number of adults, and let's give C is the number of children. If I want to create an inequality, I know that if an adult weighs 70, so 70 times the number of adults plus 35 times the number of kids must be less than or equal to the total weight, right? In this situation, I'm talking about the total weight, right? If an adult is 70 kilograms and a child is 35 kilograms, the total amount of people must be less than 150 kilograms total, right? We're talking about the weight here. This is talking about the weight of our elevator. And so try to create another equation with all of that. And of course, figure out what happens if I have at most Z people. In this situation, I have at most 15 people. But what can you write a constraint using what we have from before that connects to at most Z people? So now we're talking about how to generalize this for any equation. And last but not least, the lesson summary that covers anything I did not cover. Make sure you read it, and I will see you in the next lesson.